Hello, and welcome to Cooking with Unity. This will be our 11th episode, and this is the first time that I've used that logo, so enjoy. I'm not sure if it even went through, but hopefully it did. So, what we're doing today is continuing our little tower defense game, and maybe concluding it, depending on where we get. So, when we last left this, let's open our little test level here. We had a playfield. We had, that's loading. We have enemies spawning. You can click to place towers. We have a menu here for selecting towers, but it doesn't do anything yet. And yeah, we've got the strappings of a tower defense game. We only have one enemy type, and we only have one tower type, so that's what I'm hoping to alleviate on both sides today. And then we'll probably call it good on this little project. So, let's see what we got here. So, last episode what we did is we got the menu working, and it doesn't completely 100% work yet. So if we go into our select tower on clicked thing, okay, that's not that interesting. Where is it? What did we have doing this? Sorry, just looking around again. Okay, UI camera, here we go. So tower selector, that's what we're looking for. Tower selector, I just didn't see it there. As a matter of fact, I'm just going to do this right now so I can find things a little bit easier. Let's organize our project. This will just take a few seconds. Scripts, that's all I care about. So let's just get those in a separate category. Get the rest of them in there. Now that'll probably confuse this pretty badly. Oh, it's thinking. Alright, so now at least we have scripts in one common location, so I won't lose them in the mess of other stuff. So, go ahead and save. So here we are. We're going to the, what is it called? Back into the tower selector script. So right now, if memory serves, the tower selector is handling changing which tower is selected, but it doesn't actually do anything other than that. And what we're going to need to do is change it so that it actually spawns the appropriate tower when you spawn a tower. And we don't have new towers yet, but we'll figure that out in a second. So right now, we have set selected tower. And then we have the update, which rotates the selected tower. We're going to add a new function here that basically allows us to get the selected tower. So let's just really quickly throw that in here. Void get selected tower. And actually, it's not a void. It's a game object get selected tower. And what we're going to do is just have this return. Return. Let's see. Towers selected tower. So what this is going to let us do is get the information stored in here of which tower we want to place, and then we're going to change our. We're going to change the create tower on clicked thing a little bit here. So right now it just takes tower, but what we want it to actually do is figure out which tower and get that. So to make it easy to get at this function, I'm just going to actually do public, and we're going to also do static. This is not always the best thing to do. Basically what this means is this function will return from... Oh, wait, that won't work either, because that's not a static end. Yeah, we'll just make that a static. So we're only intending to have one tower selector in the game, so this will work. The main reason that you don't want to use static is if you want to actually get at a members variable. So like if you have an enemy class and it has a bunch of different features, which like our enemy class currently does, if you were going to change features on that, you wouldn't want them to be static because it means that all the enemies share that variable. That's what it means. Static means that every instance shares that one variable. And technically speaking, if we want this to really be robust, we'd want to set this up as a singleton, so that there can only be one of this tower selector. We're just going to assume that there is only one in this for right now, because singletons are a bit complex for right now. We'll have an episode devoted to them at some point. But basically, suffice to say that this will return... Oh, wait, that's not going to work either. I guess everything has to be static. That's a problem. Okay, I'm getting too far ahead of myself, I think. Let's just start with game object get selected tower and see what we can work with there. Yeah, alright. We'll do this a little bit differently. So instead of instantiating this public game object tower, we're going to want to do it based on the tower selectors thing. So, does send message actually return things? This might not work either. Already seems like I'm not very well organized. I didn't have a lot of time before this episode, so Unity. And I'm already kind of thinking ahead of myself. Function, apply damage, C#. Yeah, okay, I don't think it takes return values. So we are going to have to reorganize this a little bit. How can we get this information the way we want it? Alright. We'll do public game object get selected tower, and it'll still work the same way we want it to. So this needs to have access to our tower selector. So public game object tower selector. I guess I could have just renamed this one because we don't really need it anymore. And so we're going to get our game object tower equals tower selector dot get. I don't know why this isn't auto completing, but we'll just do get selected tower. Not get, just get. And we'll save this. We're probably going to have errors all over the place, so bear with me. And since I called it tower, we don't need to change this instantiate call. This will do exactly the same thing we wanted. So now let's look at our UI camera and tower selector here. We're going to need 3 tower types. So let's make 2 more regular towers real quick. They're going to work exactly the same for right now, but we're going to call it yellow tower, and we're going to call it what's the other color that we were using? Blue, I think, right? Yep. Blue tower. And for organization's sake, I'm going to put them all in a folder called towers for right now. Towers. Because I decided to name them in ways that they're not next to each other. And I'm going to put the UI towers in there as well, just because may as well. Blue tower. So now we should have 6 things in there, right? Blue tower, tower, yellow tower, tower 2 UI, tower 3 UI, tower UI. Alright, good enough for me. So let's see what this error we got. Unity game object does not contain a definition for get selected tower. Oh, okay. So what we want to actually call this then is a tower selector. And we'll see if this actually works then. Alright. Seems to be doing something. Alright, so let's now finish off the changes I need to make to these objects. So we currently just have 1 tower in here. We want these to correspond to whatever icons we have. So for the tower 2 UI is yellow, so we're going to make that our yellow tower. And the other one is our blue tower. So these now correspond 1-to-1. I'm going to actually make our towers different colors too, even though they don't do anything just yet. So this one we want to actually use the which one is this? Yellow tower. We want the yellow shader on this, and we want the blue shader on the blue tower. Alright, so if all things go well, this should actually just work. And I'm going to go back over what we just did because I don't think I really explained it very well. I was kind of thinking through it. So we have towers, we hit click, null reference exception, so obviously it's not working. Where did we get our null reference exception? So it did not get a tower, did not get a game object from the get selected tower. Not quite sure why either. Oh, probably because we didn't actually hook up. So where is the, let's see, tower selector, create tower unclicked. Where does that actually show up? Is that in the plane? Okay, there we go. So we didn't actually set our tower selector. So our tower selector is the UI camera, actually. And let's see if this works. Alright, we're getting towers. Click a different one. We get yellow towers. Now we click the blue one, we get blue towers. Amazing. Alright, so let's go over how this is working, because it's kind of complex, and but it's also, like, you saw how simple it was to get this stuff working. We kind of planned it in advance, but so basically what's going on here is when you click on this grass, this plane, it has this create tower on clicked. And actually before this, so we have my script called detect clicks and touches. This actually captures the clicks and what object was clicked and where that object was clicked. When it gets clicked, when an object gets clicked, it sends a message called clicked. It does not require a receiver, which means that an object doesn't have to handle the clicked thing. But if it does, it will do something. So create tower on clicked does exactly that. It handles clicked, and it handles it with the position. So what this means is when you click on it, this function calls and it gives you the exact position that was clicked on the object. So as soon as this happens, this script talks to our tower selector, which we've set through Unity here. So UI camera, which is our tower selector. UI camera has a script called tower selector, which makes it a tower selector. It's not entirely how it works, but that's good enough for right now. So when I do tower selector get selected tower, it checks what our selected tower is, which changes based on which tower is selected, and then gives us the game object that's described by towers here, which is set here. The UI stuff is just used for the spinning icons, and the reason I have it separate, even though they're exactly the same right now graphically, is in a lot of cases they're not going to be. You'll want a separate icon or a separate detail view or something for for what you're selecting, and then in-game it might look different. It doesn't have to. We could have set it up so that it looks the same. But it also simplifies the fact that if our towers had AI, they'd actually be operating if they were there in that preview, and we don't want them to have AI, so they're separate objects that are just used for the UI. And so basically what's happening is when we click on the ground, it's figuring out which tower is selected. And so by default, the green one's selected. And when we click the yellow one's not selected, so it spawns the yellow ones. And when we click on the blue one, it spawns the blue ones. And if we go back to green, it's green again. And yeah, that's how it works. That's how we set this up. So it's kind of cool in that regard. And now we can actually work on making our towers unique and have them actually do different things, which is the fun part. Writing behaviors and AIs and stuff are usually where I have the most fun, at least in scripting, just because it's where the gameplay starts to come about. So what I've decided on for our towers is we're going to do 3 tower types. We already figured that: green, yellow, and blue. Colors are kind of meaningless right now. They're just to differentiate it because we don't have art for these things. You could, of course, in a full game, you'd be replacing these with models or sprites or something. So what I'm planning on doing is making the yellow ones a slowdown type. A lot of tower defense games have this concept where you can take an enemy's speed and slow it down when they get hit. And these towers usually have a shorter range and shorter repeat rate on their firing, but the projectile, when it hits, slows the enemy down. And then the blue ones, we're going to make an area effect, where they will kind of lob a projectile. We'll see if we make it lob. I might simplify that for the episode, but we'll see. And then where it hits, it will explode in a large explosion that does damage to a bunch of units. So let's see here. So let's start with the. Should we do the lobbing? Let's do the slowdown one first. So the slowdown tower, the basic script for it doesn't really have to change too much because we're still going to spawn bullets. We're not doing anything special. We're just going to have the bullets shoot straight out like these ones have been doing, and we're just going to change what affects when the bullet hits. So we're really only going to have to change the bullet, but we can also adjust the way this thing fires. So we can make it so that it has a different fire rate. Let's actually make it a 1 second fire rate. And let's make the radius smaller, so radius of 3. So what will happen here is we're still going to be shooting the ping pong balls right now, but this will show you that just with a script change you can change how things operate. So that one's firing at that rate. This one fires much slower, and it's not going to acquire enemies as quickly. But when it hits them, the enemies will slow down. So how are we going to make the enemies slow down? That's an excellent question. There's a few different ways you can do it. One of the ways is you can actually modify the enemy, the instance of the enemy rather, with new information, which is what we're going to do. And then the trick is to allow it to come back to its normal information afterwards. And a lot of times people will write managers for this kind of thing, where you'll have this kind of central intelligence that handles keeping track of all the enemy states and behaviors and timers and stuff. And I tend to stay away from that myself, just because it's so powerful to have it decentralized in Unity, and it's very easy to move things around. So I'm going to show you how I'm going to work it using Unity, and you can set it up differently if you think this is a massive hack or anything. But I think you guys will like this. So we have a bullet. I'm going to duplicate our bullet. We're going to call this slow down bullet. And let's go ahead and make a new folder called bullets, because I like to put names of things before what they are, and that screws up ordering, so might as well have them in one nice spot. So what this thing does currently is nothing. That's right. Our bullets have no AI. The enemy handles when they get hit by them, and then act accordingly. What are we going to do? Are we going to keep it that way? Yeah, we're going to keep it that way. Let's look at our enemies just to see how they're set up. Basic enemy. So they have health. If they are collided by something that's tagged as a bullet, they reduce health, and if their health is less than or equal to 0, they destroy themselves. Okay, simple enough. So these bullets are not going to actually do health. And actually, we may change this so that we can actually have the health associated with the bullets, which we'll want for our explosive one, because we want our explosive one to be powerful, right? So we're going to probably change where this stuff is handled. We're not going to worry about it right now, though. So what we're going to do is we're going to create a new script, create C# script, slow bullet. Now we're going to open up our script, and alright, so we're going to do some interesting stuff here. I wonder if this will work. I think it will. So our slow bullet. This will give us some variables. Public, float, slow amount, public, float, slow time. That's probably all we're going to need for these. So these will operate when they collide with an enemy. Our enemies are tagged, right? I think they are. Let's see what they've got. Yep, they're tagged and layered, so we can really do this however we want. Let's go ahead and pilfer this on collision enter with slow bullet. And what this thing is going to do is it's going to change the speed of the enemy by a percentage. So actually I'm going to change this to slow percentage. And slow time. So we're first going to change the enemy's stuff. So we're going to check to see if the enemy's an enemy first. So it's going to be similar to this line, if collision.collider.tag. Except we're going to say enemy. Enemy. So we've hit an enemy at this point in the code. So we're going to adjust the basic enemy's script. No. Wait. How do our enemies move? It's not the basic enemy script, it's something else. It's path through objects, I guess. Let's see. Let's run the game and find out what the basic enemy is doing for logic. So basic enemy, path through objects, that's what it's doing. Alright, so that's where its speed is determined. So we're going to get its path through objects component. So enemy, okay. Path through objects script equals collision dot collider dot get component, and then we put path through objects right there. And then we can change, let's actually say script instance to be more specific. And then script instance dot speed. Is that what it was? Speed. All right. Script instance speed equals, actually let's just do times equals slow percentage. And we're going to start the slow percentage at 0.5. So this is meaningful. It will slow it down at 0.5, and that'll slow it down to half speed. Alright, so let's see how this works first. So, unexpected symbol. Oh, you actually have an equals here. So, what we're going to do is we're going to attach slow bullet to our slow down bullet here. I'm going to make our bullets green, just so that they are the same color as the towers that are spawning them. It's not going to look great from an art perspective, but so bullet. And actually, I'm sick of it enough that I'm going to do some more organization. Shaders. I'm going to throw all of these little things in here. I'm not going to worry about the auto-generated ones right now, but because they kind of organized those already with materials. And actually, I shouldn't be calling this shaders. These are materials. Yeah, let's just actually put these are materials. A shader is what a material uses to define its behavior. The material itself is the collection of shaders and textures and stuff. So there we go. They're materials now. Let's just delete shaders because we're not going to be writing any. Alright, and let's hit play again and see if we have green bullets. Okay, we do. And we're going to go down to the slow down bullet. And this thing has its script. And we're going to go into the yellow tower and change this bullet to slow down bullet. So now if everything goes well, when we select a yellow tower and it shoots at something, it slows it down. And it keeps slowing it down. Alright, that's what we expected it to do with the amount of logic that we gave it. But it's working. That's cool. It's always nice when things work. So, let's see what we got. So now we need to make this last for a certain amount of time. This happens on collision. At the point that this object has collided, it has probably destroyed itself. Wait, what is killing our objects? Is that the enemies that are handling that? Probably. I don't even know how this thing's organized. Alright, this is the one problem with kind of decentralizing, is sometimes you have to hunt things down a little bit. Where is it? Basic enemy. Okay, so it destroys the game object when it gets hit. Oh, that explains why we have one hanging behind when we kill the enemies, because it's not destroying them in every case. Let's actually fix that real quick. So we always want to destroy the collision.collider.game object, no matter what. Alright, so it handles destroying. So this object's already gone. It's out of our hands the moment that it hits the enemy. So we're gonna make it so that this thing slows it down over a period of time, though. So what I'm gonna do is I'm gonna create another script called let's see, what are we gonna what's a good name for this? Restore speed. And we're going to click on this and write a few lines of code here. Alright. So, public float original speed and public float time. And what we'll do is, should we do the invoke thing again? Yeah, it's easy enough. we're going to create a function called void restore speed. It doesn't have to be called the same thing as this, but it's what this thing is doing anyway. Oh, it's not going to let me do that, is it? Yeah, it doesn't like that. All right, so we'll just call it, because that would be a constructor. That makes sense. Restore speed function, whatever. I'm not going to spend too much time figuring out what to name things. And we'll just do in the start, we'll invoke restore speed function and time. We'll set this to 1.0f so it's meaningful. Actually, no, let's. It doesn't matter because we're going to be using this pretty much strictly programmatically. So we're assuming that the object that we have has the component that we need. So where's slow bullet? We're going to do this script instance thing again. And instead of collision.collider.getComponent, it's just going to be GameObject.getComponent. And underneath here, we're going to script instance.speed equals original speed. So after this basically starts this thing invoking. After the time elapses, it does this. And what we're going to do is we're going to attach this to an object. So we're going to actually, once this is done, we're going to delete the object. So, destroy GameObject. All right. So, so when we do this, what we're going to do is we're going to create a new object using Instantiate. So we're going to public game object. What are we going to call this? We'll just call it restore speed object. So we're going to instantiate restore speed object. And as game object. And we're going to actually restore speed instance equals, and this is a game object. And then restore speed instance, we're going to actually dot get component restore speed. And all right, so this is restore speed. We already have a script instance. Script instance 2. This will just really annoy people who have better naming conventions than me. I'm sure that I'm going to get some emails about that, and if I don't, that means that not enough people are watching my show. So, and then script instance 2, we're going to set both the public variables that we need. So, we're going to set time to equal slow time, and we're going to set what else does it need to set? Original speed. Oh yeah, original speed. That's interesting. So that's we need that earlier. Let's actually move this stuff up, making our 2 even more arbitrary. So script instance 2 dot original speed equals, I'm going to put this up higher. Equals script instance dot speed. And so what this is doing is we get an instance of our script from the attached enemy that we've just collided with. We create, no, wait. We create a new game object. We get its restore speed script. We adjust the time and original speed to be what they should be, and then we change the speed of the object. Finally, what else is going on here? So right now we're just spawning this wherever. Actually, it'll be wherever the prefab is set, which we're going to change, but this just gets it out there. The other thing I wanted to do, okay, that's it. I wanted to make restore speed instance dot parent equals collision dot collider dot game object. Oh wait, actually, dot transform. So this will make our little slowdown object a child, and we're going to add one more thing here before we check this, so I can break more and more. If that's the best way to handle this. We want to make sure that it's not already there. Like we haven't slowed it down. Or should we have it so we can multiple slow down things? Let's just try it as it is right now, see how this works. So we're going to need to create a restore speed object. So we're going to create a prefab over here. It's called restore speed object. Doesn't need to be called that, but that's what I'm calling it, and we're going to put it someplace that's not in with the scripts. And we're going to attach a definition for parent. Oh, probably .transform .parent. All right, we're going to attach our restore speed script to here. And it's not going to let me. Alright. Let's have a new prefab. We're going to work over here. Create empty game object. We're going to call this restore speed object. We're going to create a prefab of it by dragging it over here. We're going to delete the original. And then on here, we're going to add our script finally, restore speed. And now we can make restore speed object be, where is it? In slow down bullet, we have a restore speed object. We make this here. And let's see what breaks when we hit play. Alright, so we do our slowdown thing. Alright, slow it down. Is it going to speed up? Oh, no, it's not. Alright, so I don't think we actually did our speed up logic. Restore speed. Oh, okay. It might have been working, but we're not going to be able to see it very well. So first of all, what did we set for our slowdown bullet slow time? Oh, we should probably set this to something positive, like 5 seconds. Let's see. I'm going to try and catch one right at the edge of the radius so that we can see if it actually operates properly. Alright. Slowed down. It's been about 5 seconds. It hasn't sped up yet. Alright. Why didn't it speed up? Let's actually see if this gets called at any point. So we're going to debug. Welcome to debugging land. Alright, so we're going to click this little icon called Attach to Process. We're going to choose Unity Editor. We're going to attach. And then, is this thing... Okay, it's not running. So we've created this breakpoint by just clicking over here. And this will mean that if this runs, it will automatically come to here. So we're going to hit play. We're going to set it up so that should run. Okay, it did run. It took a long time. 5 seconds is a long time. Alright, so it got here. The original speed, let's see, script instance. No, this. Original speed is 2. What's our default speed on these guys? Oh yeah, the problem with doing this is Unity becomes unresponsive when you're debugging it. So what I think is actually happening is it's getting here, but since we don't check to see if this thing already has been slowed down, it's every time that it's being hit, it's getting the new speed and setting that as the original speed. So we're not seeing it jump up in speed very much once it actually gets back to there. So I do actually want to check to see if this thing already has the restore speed thing going on. So quick and dirty way of doing that could be collision dot collider dot get component in children, and we'll do restore speed. And we want if not. This might actually just work. So what we're doing is basically checking for null on this to see if that exists or not. If it doesn't exist, we're going to add one. And if it does exist, we're going to do a whole lot of nothing. So let's see if this just works right there. So we put our thing in. It hits it. It doesn't slow it down any further. And after 5 seconds, does it speed up? Is it going to speed up here? It's still not speeding up. Alright, let's look at our debug stuff again. So we're going to hit connect. Unity Editor, attach. And we hit play. And now we'll shoot at these things again. Alright, so it got here. This pointer says original speed is 2. Alright. I should have probably looked that up real quick. Let's find out what the speed of the units actually is. I have a feeling it actually is 2. Alright, whatever, stop. Where's our enemies? Enemy spawner. Spawn time, path points, spawn list. Alright. That's right, we have it on the enemy because the enemies wanted to decide their own speeds. So their default speed is 2. Let's see what their script actually does. Let's see. update, transform position, movement direction times speed times time.delta time. So it is using speed and the update, which means this should work. Alright, let's see if there's something tricky here. Oh, path through objects instance. Oh, game object dot. Wow. Surprised this didn't throw a whole bunch of errors. Restore speed function. Oh, okay. Path through objects. So this assumes that this is attached to the exact same object when it is in fact not. Did I code myself into a corner? It happens occasionally. Alright. We want an object that this is parented to. Okay, so that's what it is. Game object dot transform dot parent. This should fix it. Alright, here we go. Shoots, slows down. And let's see if they speed up a while. Okay, started moving again. Awesome. I think it is using the time that was first shot to determine whether or not it should speed up. Not a big deal. I'm not fixing that right now. Alright, so we have a slowdown thing. So now we can combine this with our other towers to make them even more effective. So we could have like a slowdown here and a slowdown here, and then just bombard with our regular towers. So the other thing I was going to do is, because we have this slowdown thing, so what's happening here, we're going to actually look at it visually. When the slowdown things hit the enemies get this child called restore speed object. And that is the one thing that actually restores their speed at the end. It's kind of a weird name for it. I would probably have changed it to be something like slow indicator. And the reason why I'd say that is because one of the advantages of setting things up this way is our restore speed object, we can actually have this look like something. So, trying to think of what would look good for slowing down an enemy. Let's just have it have a little sphere around it. Let's just do that. We don't have enough spheres as it is. So we're going to do. We're going to look at this. We're going to add mesh renderer. We're going to add a mesh filter. We set this to a sphere. We're going to add. This is. Maybe I should do this the other way where I actually just make a sphere and then attach that script to it, but this is the same thing. It's just this is what it's actually doing behind the scenes. So we've got a renderer, we've got a mesh component. We need one more thing. Need a material, so I'll just throw a material on here. We'll do yellow. So now it looks like a yellow sphere. Let's actually make a new version of yellow real quick. Let's make it transparent yellow. Where is it? Oh yeah, here we go. Duplicate transparent yellow. So this one we're going to set to a different shader. It's going to be the transparent diffuse, and then we're going to set the alpha value on the color to some low value. Let's do 90 if that looks good enough. And then where is it? Restore speed object here. I'm worried I did this in a confusing way for people, but I think people might dig this, honestly, if you kind of figure out what's actually going on here. It's actually pretty cool. So let's do transparent yellow, and let's make it a little bit bigger than default. Let's make it 1.5. I'm just doing this entirely blind, so we'll see how this actually looks. So when we hit play, now when an enemy has been slowed, and it didn't work. Alright. Probably have to actually be explicit on where we're spawning these things. So, oh yeah, that's right, because they're not childs initially. So we get to go to our script here. I was hoping I was just going to be able to do it like magic, but no. Instantiate restore speed object. So we'll just instantiate this where our enemy is. So collision.collider transform.position, and then we'll just do quaternion.identity, because it doesn't really matter how it's rotated, it's a sphere. So now when we do this, it should actually have the spheres around the enemies. Yay! And so now you can tell that they're slowed down. We can make the spheres a little bit bigger so they don't cut through the corners there. And actually, let's make them a little bit more opaque. So, yellow shader. Let's go with, whoops, not yellow. Transparent yellow. I spelled that wrong. Oh well. Let's do 128 halfway through. And, so let's see. Yeah, that shows a little bit better. And let's make them just a little bit bigger. Where is it? Restore speed object. We'll just make it 2. It's probably going to be way too big. But now, this object not only has a meaning in gameplay, but it also informs the player that the gameplay has changed. And it's pretty easy to set it up that way. And the reason that I'm basically showing you this is because it's actually really cool to set it up so that there are objects that determine state. There's a few people that use the hierarchy to determine the state. I kind of do the opposite of that. I set children to set state for these objects. So we know that they're slowed down because they have a child that has a slowdown script on them. And then that child itself can be used to render the state, as we've done here, where you can see the spheres around the enemies when they're slowed down. So there's now 2 ways you can tell that they've been slowed down. But yeah, so that took a little longer than I thought it was going to take. We didn't really get to our lobbying enemies. I'm going to go ahead and do one more episode on this, where we'll do the lobby enemies. We've got 7 minutes, though, so what should we do? Well, we could make another enemy class. Let's make a super fast enemy. And we'll have them be blue or something, and smaller. So let's make a fast enemy real quick, just to show you how easy it is to make a variety of enemies. So we're going to duplicate our basic enemy, and then we're going to change the name to fast enemy, and that will put them further away from each other again. Might need to make another folder. So we've got our fast enemy here. It's exactly the same as our basic enemy. And we actually don't even have to really do anything to make this different. So let's make it look different. So we're going to make it blue instead of red. Blue instead of red. Okay. Blue instead of red. Alright, that worked. And we're going to change it so that they have less health. Let's make it 5 health. and we're going to make it so that they move faster. We're going to make them twice as fast. And then in our enemy spawners, let's make it so they spawn from the bottom one. And we'll do a couple basic enemies and then a couple of fast enemies. And then a couple fast enemies again. So all I've done is change our spawner list here. And it should start spewing out the different enemies. So the top one will always be the basics. And the bottom one will have our speedies. There's our speedy. So that's how easy it is to make a different type of enemy. We could also make them smaller, which would make them slightly harder to hit. If we wanted to get really complex, we could have it so that the towers actually prioritize targets. So like the speed slowdown towers would always prioritize the speedy enemy. Different things like that. So that's how easy it is to get new behavior out of this. Like it's a lot of setup for the individual behaviors, but now that we've got it together, it's super easy to just change the way the game plays and to change the way the level works. And we can change the waypoints around. We could have them crisscross easily, just around the different waypoints that we've set. I really should have something that draws our path when we're in edit mode, because right now you don't see a whole lot, like until you hit play. Because what we're doing is when you hit play, the spawners themselves are creating these paths that we see, and that the enemies actually follow. So we could do something to make that visible. 4 minutes left. Is there enough time to make that happen? There might be. Let's look at it real quick. So let's look at our enemy spawner script. Enemy spawner. So what we can do here is void on draw gizmos. I'm going to have to look this one up real quick. Unity draw gizmos. I know searching for it by name is cheating. Draw gizmo. That's not it, I don't think. On draw gizmo. Okay, that is what it's called. So what this is it allows us to draw things based on the editor. So on draw gizmos. So void on draw gizmos, and all we're going to do is basically draw our path. What kind of things can we do? Gizmos.draw line. That'll be perfect. All right, so for each game object path point in path points. We're going to draw lines between them. So, how are we doing this? So, the first one is. So, we're going to draw the first one first, actually. So, between transform.position, so draw. Gizmos.draw line from to, perfect. Transform.position and path points 0.transform.position. And then here we're going to yeah, might be better to do it this way. Yeah, let's do it as a for loop here. So we're basically duplicating the behavior here, just changing it up a little bit. It's much more concise because we're not having to scale or anything. We're just drawing lines. So it will be path points. I and I minus 1. I minus 1 dot transform dot position. And let's see if this just works. So now I'm just going to hit play so that it compiles faster, because that generally happens. So now we have lines that show where the paths are. I just did that real quick because it'll help us actually see what's going on. But now if we were to create, say, a new waypoint, I'm going to go a little bit over time just to show this real quick. Let's just duplicate one of these waypoints. I'm going to call this waypoint 4. And we're going to move it over here. So now if we go into our enemy spawner, one of them, and we add waypoint 4 in there somewhere. So let's go 4, and then add waypoint 4. It'll add it to our little thing there. So that's kind of a fancy little path we made there. Let's actually get rid of waypoint 2. And so, yeah, this gives us an error because we just did this. Let's make it 3 points. And waypoint 2. Is that it? No. Let's just go directly to waypoint 4. And then player base is our final waypoint. There we go. So now we have 2 separate lines and we can see it. And as you change things, it just updates there. So now it's a little easier to see what we're doing beforehand. And all that is an on draw gizmos call, which this just executes in the editor when the object itself is asked to be drawn. So anyway, thanks for joining me. Sorry I'm 2 minutes over. I think we had a good show on this one. So we'll do one more tower defense next time, unless I have something else I need to show you desperately. And that'll wrap up this little project. Anyway, thanks for tuning in. Good night.